Check this out. Something very strange is about to happen. Something kind of horrific, actually. Look, if you have 2 to the first power and that equals 2, and you have 2 to the 0 power and that equals 1, what would 2 to the 1/2 be? Other than a nightmare because you have a fraction as an exponent. But check this out. Interesting, right? What do you think that 2 to the 3/4 might be? Is that going to be closer to 1 or closer to 2? I can't lie. 2 squared equals 4 kind of makes sense to me. But without a calculator, 2 to the 1/2 makes no sense to me. There's got to be a way to rewrite that so it shows what's happening when you have a 1/2 as an exponent. Let's try something here, and I want you to watch for a pattern. So there is a pattern to it. If you have a number that is raised to some fraction, the number that's on the top will go on the inside, and the one that's on the bottom, the denominator, will be on the outside. Let's do some examples so you can see what's going on here. If I have 7 to the 3/4 and I want to change that into radical form, 7 is the base. So that'll go on the inside. The numerator is the exponent on that base, and the 4 is on the outside. It's telling you what kind of root you're taking. You're going to take the 4th root of 7 cubed. Now for me, for some reason, that makes more sense than 7 to the 3/4 because I can't figure out how to take 7 times itself 3/4 times. Let's do it again. I have 10 to the 5/6. So that's going to be 10 to the 5th. And the number on the outside is the 6. So this is the 6th root of 10 to the 5th. 3 to the 1/2. This 1/2 is the one you're going to probably see the most often. It can be a little tricky because we think of square roots as not having a little number on the outside, and we don't usually write an exponent of 1 either. What this really is the square root of 3. So 3 to the 1/2 is the square root of 3. After a while, you're going to memorize that. Anything raised to the 1/2 just means it's a square root. There's something coming up where you're still going to need to understand a different way to write these. So I want to show you this on the calculator. So what it looks like is when you have a radical and you have an exponent on the base on the inside of the radical, you can actually pull that out, put some parentheses on there, and put that exponent on the outside. Let's go back to the numbers that we were working with. We've already filled out this chart, but let's just add another column, rewrite these radicals, and move that exponent to the outside. This may not seem like a big deal, but you're going to get problems where these are going to confuse you. Switching back and forth between these two will be helpful. The 3 comes to the outside, so we have the 4th root of 7 gets cubed instead of the 4th root of 7 cubed. On this one, the 5 is going to come to the outside, and on the last one, this one, again, turns out to just be the square root of 3 because you're bringing out a 1. So you're not really changing it. But if you see it all weird like this is what you translate it to. So it makes more sense. Let's practice a little bit more. We have the cube root of 5 squared. You're just rewriting. I'm not simplifying. I'm not going to put 25 for 5 squared. I'm just rewriting and moving all the exponents around. Our base is 5. And it's being raised to an exponent that's a fraction. The numerator is the number on the inside, and the denominator is the number on the outside. So this is going to be 5 to the 2/3. Rewriting this radical where you pull that inside exponent out, it's going to look like this. Cube root of 5 squared. Let's do it again. 7x to the 3/4. I'm bringing in some variables because obviously things get a little more complicated with variables. The 3/4 here is only on the x. It's not on the 7. The 7 is just going to come along with us for the ride, but it doesn't have any exponent on it at all. If they wanted the 3/4 on the 7, then parentheses would have been around the 7x. So let's bring the 7 along, and the x is the base inside the radical. It's raised to the 3rd power, and the 4 goes on the outside. Now for the next one, We're just pulling the 3 out. So we have the 4th root of x, all of that's being raised to the 3rd power. For this one, the 5x is on the inside of the radical sign, so that is grouped together. Everything we do with exponents is going to have the base of 5x together. This is a square root sign, so we know that this little number out here is a 2. Let's do the one in the middle first, but just bring that 3 inside. Now remember, I said that the 5x is the base, and it's all raised to the 3rd power. Then I'm not writing the 2 down. We know that that's a square root. Writing this as an exponent instead of a radical, 5x is the base. We got to group that up. The numerator will be 3 because that's the inside, and outside is square root 2, so that's the denominator. Base is 14, so that goes here. The numerator goes on the inside, so that's a 1, and the denominator goes on the outside. You're going to see these 1/3 exponents quite a bit too. The base is x, the numerator is 1, it goes on the inside, and the outside is the cube. Or is the 3. So it's a cube root of x. You do not have to write the 1. It's not wrong if you do, though. If you do not see an exponent, it's a 1. So this is b to the 1/3. This one's tricky. That exponent, 1/2, is only on the x. It's not on the 5. 5 is just coming along for the ride. So this is 5 times the square root of x to the 1st, which is 5 square root x. Another one of these where the exponent is only on the thing next to it. You see no parentheses to group these up. So this is 19a times the square root of b. That exponent is only on the y. 17 is just coming along for the ride. So 17, the 2 is on the inside, the 3 is on the outside, so it's 17 times the cube root of y squared. This problem is why I showed you that 3rd form. Exponential form means I want the fraction exponent. The first step I'm going to do is move that 3 to the inside. So it looks like something that looks a little more familiar to me. The inside is 3, the outside is 4, so this is y to the 3/4. If you're not sure how to start, you see a square root sign, put a little 2 there. It's going to help you think about what the next step might be. The 12n is underneath the radical, so that is all grouped, and whatever we end up with as an exponent will be applied to the 12n together, so I'll keep parentheses on those. The first thing I'm going to do, though, is bring that 3 on the inside. Notice I grouped my 12n. If I didn't group them, that 3 exponent would look like it's only on the n, but it's on everything. So now I have 12n as the base. The exponent will be 3/2. Now you may be working on exponential equations next, depending on the class that you're in. If you are, check out this video. I'll see you guys next time. Bye.